Let's look at another example. Here we have a region D, which is bounded between two circles, one of radius 2 and one of radius 3, and we've taken just the right half. And we want to integrate the function x squared plus y squared over that region. As before, our first step is to describe this region by figuring out the range of r values and theta values to use. Now we see that every ray that we send out from the origin enters the region on the circle of radius 2 and exits on the circle of radius 3. So the range of r values is just 2 to 3. Now the range of theta values is a little bit trickier. We have to be careful with how we pick our range of angles here. Because, for example, you might think of this angle down here at the bottom usually as something like 3 pi over 2, and this angle up here at the top as pi over 2. But if you write 3 pi over 2 to pi over 2, well, strictly speaking, what I've written is kind of nonsense. There are no angles that are bigger than 3 pi over 2 and less than pi over 2. Or maybe I should say there are no numbers that are in between 3 pi over 2 and pi over 2 that way. So we have to find some other way of representing this. Well, in this case, the important part for integrals is to make sure that whatever value I put on the bottom is actually smaller than the value I put on top. And so, for example, we could do negative pi over 2 to positive pi over 2. Or if you felt like it, you could do 3 pi over 2 to 5 pi over 2. So you can use different representations of these angles, but you just have to do it in such a way where as you go from your lower bound to your upper bound, that you traverse exactly once from this bottom angle to the top angle. Okay, well, I'm going to go ahead and stick with negative pi over 2 and pi over 2. The next thing is to convert the function to polar coordinates. Now, if you've done a few of these, then you start to just say, oh, right, x is r cosine theta, and y is r sine theta, and so that means I have r squared cosine squared theta plus r squared sine squared theta. And then you say, oh, well, I can simplify that. They both have an r squared in them. So I can pull that out. And then, oh, right, cosine squared plus sine squared is just 1. So you just get r squared. All of that's true and fine, but you probably would do better to just remember that x squared plus y squared equals r squared. That was one of these polar coordinate equations, and it'll save you a lot of headache to just remember that part. So we end up with the integral of r squared times r dr d theta, where r goes from 2 to 3, and theta goes from negative pi over 2 to pi over 2. Well, so of course, this function on the inside is r cubed. So when I do the inside integral, you'll get 1/4 r to the 4th from 2 to 3. Well, 3 to the 4th is 81. 2 to the 4th is 16. And so you end up with 65/4 from the inside integral. And you still have to integrate with respect to theta. But since there's no theta here, you just get 65/4 of theta. And theta goes from negative pi over 2 to pi over 2. So 65/4 times pi over 2 minus 65/4 times negative pi over 2. And that ends up just giving you 65/4 times pi.